Good day, fellows. Sezo is back. Let us continue with the concept of Euclidean geometry. Then now they gave us that ADF is a tangent to circle with points E, B, C, and D. Yes, ADF is a tangent. ADF is a tangent to circle with E, B, C, and D. Yes. Then they also gave us that AB is parallel to DC, AB is parallel to DC. Yes, we can see with these notations. Then lastly, EC is equals to DC. EC with these two lines equals to DC, these two lines. Yes. Then now, let us try to answer this question now. This question, the first one is going to be, if CDF is equals to X, like this, name with reasons. C with reasons 5 other angles equal to X. You see? Then how are you going to answer this question? Then let us go to our diagram. We have X over there. Firstly, let me take you back. You see? Let me take you back. We have something like this. You see? Somewhere here we have X. We have D, somewhere here we have F and C. Then somewhere there we have E. Let me write E2. You see, we have E2 somewhere there. Do you see that this angle is going to be equals to this one? Do you still remember the reason? Stand chord. You see? Then now we are going to say angle E is going to be equals to, let me say, CDF. Yes, CDF, like this, which is tan chord. You see, eventually, let me say E2 to be specific. Eventually, angle E2 is going to be equals to X, like this. You see? Then let me continue. Let me erase here. Okay, now we know that E2 is going to be equals to X, and they also gave us that EC is equals to DC. Do you still remember this triangle? This triangle, the isosceles triangle. Let me write two lines. Whenever these two lines are equals, the base angles also they are going to be equal. You see? Somehow angle E2 is going to be equals to angle D2. The reason that we use here is going to be the angles opposite equal side. You see, eventually angle D2 is going to be equals to X as well. You see? Now let us continue. Okay, let us continue. Now we know that here we are going to have X. Let me write X in here. Now we want the remaining. Check. They gave us that these two lines, they are parallel. And whenever if we have parallel lines, you just need to remind yourself of this concept. You still remember the concept of fan, corresponding co-interior in alternate angles. Do you see angle, let me say angle A is going to be equals to CDF. CDF is going to be corresponding. This X is going to be equals to this. You see, we get an F shape there, like this. This angle is going to be equals to this. Then now we write corresponding angle Y because AB is parallel to DC. Eventually, the angle of A is going to be equals to X as well, you see. Then now we also have an N, or some they say a Z shape. Check E1. We have E1 like this and D2, you see. They form Z shape. Z shape like that. Or N shape, you see. Then we are going to say angle E1 is going to be equals to angle D2. Reason is alternate angle, you see, corresponding angles somewhere here, alternating angles, while AB is parallel to DC. Then our angle E1 is going to be equals to X as well. X as well. Then so far we have 1, 2, 3, 4. We need the last one. Okay, as for the last one, check. We have this theorem again. Let me draw somewhere here like this. Let me draw something like this. We have something like this. I hope you can see. Somewhere there we have C. Somewhere there we have D, B, and E. Let me say 1. You see the exterior angle of a cyclic quad E1 with C. You see C1 and C2 is going to be equals to E1. You see angle C1 plus angle C2 is going to be equals to angle E1. The reason for this, exterior angle of cyclic quad, eventually angle C1 plus angle C2, they're going to be equals to X. Just like this, we have managed now to figure out our 5 angles that are equals to X. You see, just like this. Then now let us try to answer the second question. Let me erase again here. Let me erase. Okay. Here. See? Like this. Then now, number 2. Now we need to prove. That A, B, C, D is a parallelogram. You see, we need to prove that A, B, C, D is a parallelogram. And now, how are we going to prove that this one is a parallelogram? Let me write something like this. We have A, B, C, D like this. You see, we need to prove that this one is a parallelogram. Then now, how are we going to figure out or to prove that this one can be a parallelogram? You see, if only we can find that this one is parallel to this one, you see, and also if we can find any other of these reasons, you see, let's say in alternating angles or either co-interior angles, then on this one we won't have into the corresponding angles. You see, if somehow we can find, let's say these two lines, they are parallel, then we are on the right track in terms of the proof for A, B, C, and D. You see, firstly, we can say we know already that A is x. You see, we know already that A is x. Then now, let us try to figure out the angle of B by considering the fact that we have this cyclic quad. See, we have B over there, D and B over there. They gave us this one to be x, like this. We know that the opposite angles of a cyclic quad, they are supplementary. We can then say angle D2 plus angle B is going to be equals to 180 degrees. Why? Opposite angles of cyclic quad, like this. You see, just like this. Don't forget that we need to prove that these two lines are parallel. These two lines, they are parallel. Immediately after doing this, we can then now say the value of D2 is x, we know, plus angle B is equals to 180, like this. Then let us take x to the other side. Oh, sorry about 1b. We are going to get 180 degrees minus x. Then this one is going to be our B, which is 180 degrees minus x, like this. Immediately after doing this, now we are going to add the angle of A plus the angle of B, just to see what is going to happen. The angle of x of A is x, plus of B is 180 degrees minus x. X is going to cancel x, then we get angle A plus angle B to be 180 degrees. Then now, do you still remember, if two angles, let's say this one and this one, we get 180, then that type is going to be what? A co-interior angle. Then this tells us what? That AD and BC, they are parallel, you see? Then now we can then say AD is parallel to BC. Why do we say so? We get a corresponding, co-interior angles to be 180 degrees. At this point, we can then say ABCD is a parallelogram. Why? Opposite sides are parallel. You see, do you still remember AB and DC were also parallel? You see, we also managed to figure that AD is parallel to BC by proving the fact that A and B, they are equals to 180, which is what? A co-interior angle, like this. I thank you, fellow, and enjoy.